In this sample problem, we're asked how many moles of copper-2 nitrate are required to completely react 0.200 moles of zinc metal. First thing we always have to do, any chemical reaction, we need a balanced chemical equation. So we have copper-2 nitrate. That'll be CuNO3, 2. This will be a solution. It's reacting with zinc metal, which is Zn solid. Now, we're not told what the products are, but I see this as a single replacement reaction. So the zinc will take the place of the copper, and then the copper will be on its own. Nice thing about this reaction, it's already balanced for us. We see that we have one copper on each side, we have one zinc on each side, we have two nitrogens on each side. So in this particular chemical reaction, what I'm going to do is I'm going to write down my knowns and my unknowns. My known here is that I know I have 0.2 of a mole of zinc. My unknown is the number of moles of the copper-2 nitrate that will react with it. Now, the nice thing here is because this is mole to mole, it ends in the same units. So we don't have to worry about any unit canceling with this. But there's other information we need as well. We need to know what the ratio is. So, important thing to remember here is that when there is no number written in front, it's actually a 1. What we are going to do is we are going to create one more term. There's no value for this, but I like to write it out ahead of time. We know that there is going to be a 1-to-1 ratio between zinc and copper-2 nitrate. We started with zinc, so zinc is going to go on the bottom. And then we want copper-2 nitrate in the end, so it goes on top. And what I'm going to do as I'm building my chemical reaction is I'm going to start on the side where I know things, and I'm going to work over in a semicircle towards the side that I don't. So here's how I'm going to build this I'm going to build this mathematical equation. In the end, I want to know the moles of copper-2 nitrate. I'm going to start with my known value, which is 0.2 of a mole of zinc. This is the big important difference with stoichiometry. We need to write down the chemicals involved. Then I'm going to unit cancel out the zinc and switch it over to copper-2 nitrate. This is why the zinc has to go on the bottom of this ratio. The two zincs will cancel out with each other, gives us the number of moles of the copper-2 nitrate. And what we do find here is that the number of moles of copper-2 nitrate and of zinc in this reaction will be the same because they have a 1-to-1 ratio. That makes sense. I've run out of space a bit, so I'm going to write my copper-2 nitrate below. Really important thing with stoichiometry, you always have to write out the chemical as part of the units too. It's not good enough to say 0.2 of a mole. You have to say 0.2 of a mole of copper-2 nitrate. In a second sample problem, we are asked how many moles of carbon dioxide are produced when 4 moles of oxygen react in propane, C3H8, combustion. This one's going to take a bit more work because we're going to need to balance out this chemical reaction. So we see that this is hydrocarbon combustion. So C3H8 gas plus O2. Remember, oxygen is O2. It's not just O. Will produce carbon dioxide gas and water vapor. Okay, we need to balance this out before we do anything else. We have carbon, hydrogen, and oxygen. I'm going to split this up into reactants and products. I have 3 carbons, 8 hydrogens, 2 oxygens on my reactant side. I have 1 carbon, I have 2 hydrogens, and I have 2 plus 1 equals 3 oxygens. I always do 2 plus 1 instead of just writing out 3, because this way I can track how many oxygens are in the carbon dioxide and the hydrogen separately. Okay, first thing I'm going to balance out, I need to have 3 carbons on each side. Anything that I multiply down at the bottom, I have to add as a coefficient up top. That's going to change my number of oxygens as well. So now I have 6 plus 1, 7 oxygens in total. Next, I want to balance out my hydrogens. I'm going to have to multiply it by 4. That will give me 8. I'm going to have to put a 4 in front here. And again, that's going to change my oxygens too. Now I have 6 plus 4 oxygens. I have 10 in total. Okay. Last thing I need to do, I need to balance out my number of oxygens. 2 times 10, or 2 times 5 will give us 10. So I have to put a 5 in front as well. There, now I have everything balanced on both sides. I have 3 carbons and 8 hydrogens on each side. I have 10 oxygens on each side. I'm going to go ahead and erase all of this balancing because I'm going to want to write underneath this chemical reaction too. I could also just rewrite it down below, but this is quicker. Okay, next thing I need to do, I need to figure out what I was given and what I want in the end. I was given 4 moles of oxygen. So I know the number of moles is equal to 4. I want to find out how many moles of carbon dioxide will be produced. So I have an unknown number of moles for my carbon dioxide. I'm starting with oxygen, which means when I build my ratio, oxygen goes on the bottom and my carbon dioxide goes on the top. So I end up with a 3 to 5 ratio. Now, if you accidentally flip the ratio upside down, don't worry about it, because you will notice that with the unit canceling. Because what you're going to do when you write this out is we're going to go this time from left to right. We always follow that curve, and it'll make more sense once we start adding molar mass, why I'm doing this curve instead of just a straight line. But we're going to start with our moles, add in our ratio, and find out our final number of moles. When I start with my beginning number of moles, I'm going to write 4.0 moles of O2. Really important in stoichiometry that you do that. Now, when I add my ratio in, the ratio has to cancel out. If I accidentally wrote 5 over 3, I'd see that, oxygens are both on the top, right? That doesn't cancel out. So I know I would have to flip it around to 3 over 5. So don't worry too much about making sure you get the ratio right. As long as you have the correct 2 chemicals involved, you can always double check that you've got it correct using unit canceling. Okay, this makes sense. We want to cancel out the number of oxygens to tell us the number of carbon dioxides in the end. Then when I plug this into my calculator, we have 4 times 3 divided by 5. That's going to tell us that in this reaction, we had 2.4 moles of CO2 produced.